Okay, so basically what's going to happen in this case is you're going to be given an equation of a relation, and you have to determine whether it represents a function or not. Okay? And notice the way it's written, it says determine if the equation defines y as a function of x. So what you want to do is try and get y by itself, if possible. There might be one or two in which you won't be able to, but in most of these we're going to use a t-table. But if possible, you want to try and get y by itself. So for example, let's suppose I had this equation, y plus 2x equal 3. Y plus 2x equal 3. So the question is, does that equation represent a function? Now, if the graph was given, it's pretty easy to determine. Use a vertical line test. But the graph is not given. You're given an equation instead. But sometimes in your toolkit, in your toolbox, you have enough knowledge to do some of this. So, for example, in number 1, do you know what the graph of this looks like? Do any of you? It's a line. Because what kind of equation is this? Linear. And you notice that this is a line then, right? So if I get y by itself, I get y equals 3 minus 2x, yes or no? You agree? Huh? What'd you say?
Our paper is a y minus 2x equals 3.
What? Oh, no, that's a different paper.
Oh.
Don't even look at that anymore. No, just, what paper are you talking about anyway? Oh, that's your worksheet. I'm not going to do the problems in your worksheet.
I thought you were.
No. All right. All right, so y equals 3 minus 2x. Now, remember, for test 1, you had something like this. You were asked to graph this. So if you were to graph this, it would be what kind of figure? It will be a line. Now, there's only one line, though, that's not a function. Do you remember the vertical line test? One line that's not a function. A vertical line is a line that's not a function. It's x equal, right? X equal a number. So with something like x equal 5, then that would not be a function. All right, now, I'm going to come back to this one, but let's talk about this in terms of a t-table then. So if I look at this in terms of a t-table, remember the definition of function says that for each x coordinate, there's got to be what? One y coordinate. All right? So for some of you know that this is a line. All right? You know it's a line, so it's going to pass the vertical line test because you know it's not a vertical line. Let's look at this, though, in terms of a t-table. Let's kind of verify that that's true. If x is 0, what's my y value? I get y equals 3 minus 2 times 0, which is what? 3, right? So when x is 0, I get only one y value. What is it? 3. Remember, the definition of function for each x coordinate has got to be exactly one y coordinate. But you got to check some more, though. You can't just do 1 or 2 or 3. If x is 2, let's say, what's the y value? Y equals 3 minus 2 times 2. So that's y equals 3 minus 4, which is what? Negative 1. So far, is this a function? Yeah. Now, always, if possible, check positive and negative numbers as well. So let's check negative 5, let's say. Negative 5. If x is negative 5, I get y equals 3 minus 2 times negative 5. So that's 3 plus 10. Negative 2 times negative 5 is positive 10. So you get 13. So think about this. If I kept on going, in your mind, that's what you got to ask yourself. If I kept on going, if I did some more numbers for x, would I get exactly one y value? Yes or no? Yes, you would. All right, so this is a function. So y defines, so this equation defines y as a function of x. So y is a function. This is a function. When I go over here, though, remember when I had that x equal 5? Now notice there's no y coordinate. The variable y is not there. But let's think about this. Let's do this in terms of the t-table. Remember, this means that x always equals 5. So that's what that means. So if y is 0, what's x? 5. If y is 2, what's x? If y is -3, what's x? And so on. You can stop there. Because you know in that mapping, if you look at this in terms of a mapping, there's only one x coordinate. What is it? It's 5. And there's an infinite number of y values that are associated with it. And so on. Notice, is this a definition of a function? No, remember it says this, for each x coordinate there's got to be exactly one y. When x is 5, there's an infinite number of y values. So that's not a function. All right, let's look at number 2. Suppose number 2, I had -2x squared plus y equals, let's say, -2. -2x squared plus y equals -2. Get y by itself if you can. Can I easily get y by itself? Yes, I can easily get y by itself. I'm going to add 2x squared to both sides. And so I get y equals 2x squared minus 2. That's what I get. Now you know that's not a linear function. But what kind of function do you think this is? Quadratic. And what's the shape of a quadratic? Now, I should not use the word function. You know this is not a linear equation, but it is a quadratic equation, right? I got y by itself. Now, if we were to graph this, what would the graph look like? A parabola. A parabola. In fact, it's going to be a parabola that's going to open up. Now, we're going to talk about open up and open down in a little while. But it's open up, and you notice it passes a vertical line test. But even if you did not know what the graph looked like, use the t-table. Use the t-table. If x is 0, do I get one y value? If x is 0, I get 2 times 0 squared minus 2. That's what y is. And 0 squared 0, what's 0 times 2? And so 0 minus 2 is a -2. So far, it works, right? When x is 0, there's only one y value. What is it? -2. We got to check a few more. If x is, let's say, 3, do I get one y value? Well, let's see. I got y equals 2 times 3 squared minus 2. What's 3 squared? 9 times 2 is 18 minus 2 is 16. Now remember, I picked the value for x and I plugged it into here, right? So think about this. No matter what I plug into x and I square it and I multiply by 2 and I subtract 2, am I going to get just one y value for x each time? Yeah, you will. Let's check -3. Let's check -3. I get y equals 2 times -3 squared minus 2. What's -3 squared? 9 times 2 is 18. 18 minus 2 is 16. Now remember, don't let that fact that I have 2 y values 16 throw you off. Remember, it's okay. It's okay for the y values to have multiple y values. I'm sorry, to have the same y value for multiple x values. All you gotta look at is this. When x is 3, what is the only y value I get? 16. When x is -3, what is the only y value I get? 16. So that's a function. No matter what other number I use for x, there's only going to be one y value here. So that's a function. Okay? Now, let's look at number 3. X squared plus y squared equals 16. What do you think? Is that a function? Not a function? Why is that not a function? Because of what? It's the graph is a circle, yes. Remember you had circles in the last test? X squared plus y squared equal 16. So you have a circle because both x squared and y squared are being, x and y being squared. So that's a circle. In fact, let me ask you this, and you should be able to tell me this. Where's the center? At the origin. Good. What's the radius? Very good. 4. So here's a circle. That's that graph. So it fails the vertical line test, right? But let's suppose for some reason you did not know it was a circle. Get y by itself. Get y by itself. Now remember, this is not just y, it's y squared. But I still want to get y by itself. So I'm going to subtract x squared from both sides, just like this. And so I get y squared equal 16 minus x squared, right? Now how to get y by itself? Square root. You take the square root of both sides. I'll go ahead and rewrite this over. Well, remember, you take the square root of both sides, what else must you put? Plus or minus. Good. Plus or minus. So that means that y equals plus or minus the square root of 16 minus x squared. Now, watch what happens. Now, you make sure you put plus or minus. If you didn't, you would not get the right answer, unless you knew it was a circle. I want you to see something. Remember, if possible, always use 0 first. If x is 0, watch what happens. I get y equals plus or minus the square root of 16 minus 0 squared, right? What's 0 squared? What's 16 minus 0? What's 16 minus 0? 16. What's plus or minus square root of 16? Plus or minus 4. So that means that when x is 0, there are how many y values? 2. I can stop right now. I don't have to do anything else like I did the others. Because this says that when x is 0, you don't have just one y value. How many y values do you have? 2. So this is not a function. Okay, that's not a function. All right, number 4. X equal the absolute value of y minus 1. Now that's just a little bit tricky because you want to try and get y by itself. The problem is that that's an absolute value equation. And y is located inside the absolute value bar, so there's really no way to get it by itself without having to do something else. But that's okay, because what letter is by itself? X. So let's look at it that way then. So if I look at a t-table, and remember x is by itself, right? So I'm going to choose a number for y. If y is 0, I get x equal the absolute value of 0 minus 1. What's 0 minus 1? And what's the absolute value of a negative 1? 1. So when y is 0, what's my x value? 1. So far, I'm okay. When x is 1, what's the y value I get? 0. All right, let's do some others, though. Let's try if y is 1 this time. If y is 1, I get x equal 1 minus 1. And what's 1 minus 1? And so I get absolute value of 0, which is just what? 0. So when x is 0, what is my y value? 1. So it looks like it's a function. But you got to try some others, okay? If y is 2, let's see what happens. I get x equal the absolute value of 2 minus 1, which is the absolute value of what? 1, which is what? 1. All right, now, do I keep on going? No, I don't. Because what did you notice about x here? I have 1 listed twice. So that means that when x is 1, what are my y values? 0 and what? 2. That's not a function. So that's why with some of these, you really need to try different things until you kind of exhaust your possibilities, so to speak. All right. So that's not a function. In fact, the graph looks like this. It's a sideways graph like that. Remember, absolute values at V, but it doesn't go up or down, it goes sideways. So that fails the vertical line test. That's what that looks like. So whenever you get x, whenever it's x equal the absolute value of y, that's that sideways. Now that's a little bit more difficult to figure out because depending on what you chose for y, it may take you a while to get the same x value. I mean, you could have kept on going. See, I lucked out and I chose the correct numbers for y. If you want to, let's say, choose, let's say -1 for y. I get x equal the absolute value of -1 and a -1. So that's the absolute value of a -2, which is just what? 2. So I get 2. So let's try for y. Let's say, for y being, let's say, -2. So let's see if that's going to help. So I get the absolute value of -2, -1, which is the absolute value of -3, which is 3. So see, if you had not gotten the x to be 1, you would have kept on going. At that point, some of you would have said that's a function. But it's not. That's a little bit more difficult. You got to try different things. If y is, let's say, 4. If y is 4, I get x equal the absolute value of 4 minus 1, which is the absolute value of 3, which is what? 3. So if y is 4, I get 3. So notice here, I get the same x value and 2 what? Different y values. So it is possible to try different things and get this situation where you realize it's not a function. But I want you to remember this, though. X equal, well, y equal the absolute value of x. Remember what that looks like? Y equal the absolute value of x? And that's this. That's at V, where the vertex is at the origin. Kind of makes sense because, look, y equal absolute value of x, the t-table. If x is 0, what's the absolute value of 0? 0. If x is 1, what's the absolute value of 1? If x is -1, what's the absolute value of -1? If x is 2, what's the absolute value of 2? If x is -2, what's the absolute value of -2? So if I look at this in terms of a graph, 0, 0, 1, 1, -1, 1, 2, 2, -2, 2, I get this. And is that an even function?
Yes.
Yes, that's an even function. What I'm saying, though, is this. If you had x equal the absolute value of y, that the graph is a V. It has that same shape, but it's in a different direction. So watch. Remember, x is by itself. So if y is 0, what's the absolute value of y? What's the absolute value of 0? I'm sorry. 0. So x is 0. If y is 2, what's the absolute value of 2? 2. So x is the absolute value of 2, which is just 2, right? If y is -2, what's the absolute value of -2? 2. If y is, let's say, 1, x is the absolute value of 1, which is what? 1. If y is -1, x equals the absolute value of -1, which is 1. And if I look at the graph this time, 0, 0 is here, 2, 2, 1, 2, 1, 2 is here. Now look, 2, -2 is here. You see it? 1, 1's here, 1, -1's here. You see what the graph looks like? So x equal the absolute value of y is a v that's pointed sideways. So it fails the vertical line test. But if using a t-table, you knew it would not have been a function because look, when x is 2, how many y values did you get? 2. When x is 1, how many y values did you get? 2. So you knew it was not a function. All right. Now let's look at. Let's write this as number 5. Okay, number 5. Suppose we had this: y squared equal x plus 4. Y squared equal x plus 4. Don't make this difficult. Get y by itself. How do you get y by itself? Huh? Take the square root. But remember, when you take the square root of both sides, you got to do that plus or minus. Okay. And you see that the fact that you have y equal plus or minus the square root of x plus 4, you should know that that's not going to be a function without even doing anything else. Why? Because the plus or the minus. So no matter what you plug in for x, y is going to be a positive and a what? Negative. You see that? So for example, if I let x be 0, I get y is plus or minus the square root of 0 plus 4. So that's plus or minus the square root of 4, which is plus or minus what? 2. So when x is 0, how many y values are there? 2. See that plus or minus? That should give it away. 6, y equal square root of x minus 1. Now don't confuse that one with the previous one. The previous one, you got y to be what? The previous one, you got y by itself, you got y to be what? Plus or minus. Here, I'm telling you that y is just the square root of x minus 1. So that's not the same thing as number 5. So when I look at this in terms of the t-table, if x is, now I can't use 0 this time. I hope y'all see that. Because if I let x be 0, that's not part of my domain. Because look, I get the square root of 0 minus 1, which is the square root of negative 1. That's not a real number, right? So you got to pick values for x that gives you real numbers. So I can't use 0. Give me a value for x. That's going to give me a real number back. You know what I mean, right? Square root of a negative 1 is at I. Remember that? That imaginary number? Give me a number. We said 5. If x is 5, I get y is the square root of 5 minus 1. Square root of 4, which is what? 2. So far, is that a function? Yeah. For when x is 5, I get one y value. It is 2. Is that going to work always for that one? Why not?
Oh, wait. I think I misheard you. Never mind.
I don't have a plus or minus, do I? No, I just have. So you got to think of it this way. Y's by itself, and then I'm thinking, okay, I'm picking some numbers for x. When no matter what I choose for x, if x is, let's say, 8, I'm going to plug in 8 into here, and is that going to be just for 8? Will that just give me one y value? Square root of 7. So when x is 8, I just get one y value. What is it? Square root of 7. If I let x be, let's say, 10, and I can't use any negative numbers, by the way. Y'all see that for this one? Because if you let x be negative 2, that becomes a negative 3, and the square root of a negative 3 is not a real number. That's that I, that imaginary number. So let x be 10. Do I get just one y value? Y equal the square root of 10 minus 1, the square root of 9, which is what? 3. So do I get just one y value? Yeah. So what can you say? That's a function. Now you had, last semester, we didn't do it in here, but last semester you graphed the square root function. It looked like this, by the way. For this one, it looks like this. I'm sorry, that's... It starts at 1. Looks like this. Does it pass the vertical line test? Yeah. Now, you probably didn't remember that. You didn't have to know what the graph looked like. Just use a t-table. For each x, there's only one y value. That is, that type of problem, what we're doing now, given an equation, determines a function, that's not an easy task because it involves quite a bit of work in terms of a t-table, making sure you choose the right numbers, and so forth. Okay, number 7. Number 7. All right, and 7, let's suppose we had this. Y equal x squared minus 5. Sometimes you can tell right away if it is. Function, not a function. And why? What do y'all think? Y equal x squared minus 5. That's a function. I didn't even do a t-table. How'd you know that was a function? Why? Anybody? It's a quadratic equation, so the graph's going to be a parabola. So it passes the vertical line test. Even if you did not know that this was a quadratic equation, use a t-table. Y is already by itself, isn't it? And so compare that, number 7, with what we did in number 2. Number 2 is also what kind of equation? Quadratic. So I got a graph of a parabola. I went further with that, though, and I got y by itself, and then I used a t-table. The same thing here. Y is already by itself. It's what kind of equation? Quadratic, so your graph's going to be a parabola. Pass the vertical line test. Use a t-table. If x is 0, do I get just one y value? Y equals 0 squared minus 5, which is just what? Negative 5? When x is 2, do I get just one y value? Yes or no? Yes. Y equal 2 squared minus 4. I'm sorry, minus 5. 4 minus 5 is a negative 1. No matter what I plug in for x, I'm just going to get how many y values? Just 1. So that's a function. Number 8. Y equal plus or minus the square root of x minus 1. Not a function right away. Because of what part? Plus or minus. Right? Because look, if I let x be, let's say, 4, I can't use 0. I cannot use 0 because what's 0 minus 1? Negative 1, and the square root of a negative 1 is not a real number. So if I use 4, though, I get y is plus or minus the square root of 4 minus 1, which is plus or minus the square root of 3. So notice that when x is 4, how many y values did I get? 2. That's not a function. Okay, one more, number 8. Oh, number 9. So in that worksheet, I think maybe we did enough problems for that. Yeah. So you should be okay now from that worksheet. Yes or no? Well, all of them, all those problems. Yeah, you should be okay. All right? Okay.